Hi, I'm outside Kansas City. I thought I'd record for a moment about code sets in the architecture picture. So there's a number of different kind of code sets that exist in the architecture picture. Certainly if we take the source systems have very disparate set of code values. All sorts of different products, all sorts of different systems, things that have grown up over time. There's lots of different ways of expressing different values that exist there. Male and female may be recorded as M and F in some systems, 1 and 2 in other systems, or something else. So there's all kinds of disparity in the data structures that exist outside the system. As it goes through the first layer, the data integration layer, you remember that the general ledger, the chart of account, is a consistent data structure that exists across those pieces of the enterprise that feed that ledger. And if we have a single ledger for the entire company, then the data structures are going to be consistent across all the products, across all of the inputs, all of the business processes involved. So we have to go from this disparate data structure to a very common data structure in the middle of the architecture. The data integration layer is the thing that allows us to do that. It starts with very disparate values, but as they go through the data integration layer, both the accounting rules and the other transform engines, they convert more and more until when they're finished that layer, they're in platform values in the code set described in the platform. Now, as we go outbound from the ledger and the instrument ledger and those layers, in some cases we have to go back out to disparate data values. In some cases we produce extract files that have to go back out to other kinds of systems, other interfaces. Sometimes even our source systems receive values that come off of the platform that describe what the balances were or other kinds of things. And so in some cases we have to reverse translate or translate out to new values. There's reporting packages that have specific values. Our government entities give us descriptions that they need to have placed on their reports. So there's data disparity again on the reporting side, maybe not as much as on the inbound side, but we again go outbound from the data transformation layers and this and in our reporting layers and the rules processes that go and build our extracts, our outbound extracts, again we have to translate out to a different set of code structures. In some cases we have to think about how the air handling works. We've talked a little bit about this. Air handling, in a certain sense, in some cases has to deal with when we don't know how to translate these inbound values into platform values. We have a couple of different choices we could do on error handling. One thing we could do is we can reject transactions. It's not a real good answer to reject transactions because we like to have control and know what the balance is associated with business events, even if we aren't able to put them into a correct bucket or correct code structure initially. We'd like to record those as soon as we can. So reject is something we can do, but usually the reject queue has to be very short period of time where it gets corrected and refed in. Often all that is adding into our translation rules new values that allow us to translate from something that's been added to the source systems in some way and get it into platform values. Another way of handling errors is a suspense approach. Suspense puts on some value that we know says that this is not the right value, but we don't know what the right value is. That increases our ability to do reconciliation and control because now the balance is at least recorded in the platform, even though it's recorded in a bucket that's not a known proper place for it, and we'll have to adjust those things as they go out of the platform in some way. Our detailed calculation engines can add new values because doing a allocation process, in a sense, is adding new values. It's creating detail where detail did not exist. And to create detail requires new attributes to be assigned in order to store new values and understand what the detail is. So there's a process of creating new values that go on in the calculation engines in some way. All of these processes, you can see, they come down to a lot of understanding of data, how data structures are stored, how data is recorded, And keeping track of that data is very valuable. It's time consuming, it's costly, but it's very important to do in our business enterprises.